Alright guys, what's up? It's Mr. Moore here. We're going to do a little physics review for the test coming up on Tuesday. I hope you guys are all enjoying your weekend. It's 7 o'clock on a Saturday, so we're going to have a fun night of physics right here. It's exactly what we're going to do. So, question 1. A 0.5 kilogram cart is rolling at a speed of 0.4 meters per second. If the speed of the cart is doubled, then the inertia of the cart is what? So this is a special vocab word, inertia here. In class we learned that inertia depends only on the mass of the object. That's the only thing that matters. Inertia is kind of an object's ability to resist change in movement. Right now I'm sitting at this computer. I have inertia. I don't want to stand up. I'm being a little lazy here. No, but really, inertia only depends on the mass of an object. So speed has nothing to do with it. If you double the speed, it doesn't matter. The mass is still the same. So the inertia is going to be unchanged. So question 2, which object has the most inertia? Once again, this is inertia, so it only depends on mass. The speed of these objects has nothing to do with their inertia. Mass only. So let's just look. Which one has the most mass? That one will have the most inertia. And it's number 4. All right, question 3. As the mass of an object decreases, the inertia will, inertia only depends on mass. So if the mass is decreasing, then the inertia will also decrease. All right. Question 4. 3 forces act on a box. If the box is at rest, then the net force acting on it is equal to what? So, if the box is at rest, then the net force is going to be 0. All right? Because objects at rest remain at rest unless acted on by another force. So if this object's at rest, it means that the net force on it is 0. All right? You could also look at F equals ma. If the object is at rest, okay, that means its acceleration is 0. And if the acceleration is 0, then the net force on it is also going to be 0. Let's do a little zoom out here, a little too zoomed in. Alright, so here we go. Which graph best represents an object in equilibrium? So we talked about equilibrium before. Equilibrium is when all the forces are balanced. All right. So if I had something like 5 newtons to the right and another force that was 5 newtons to the left, this would be equilibrium. These two forces are going to cancel each other out. So the net force on these is 0. So when you have equilibrium, that's like having a net force of 0. So we have to look which one of these graphs goes with a net force of 0. Well, like I said before, if F equals ma and the net force is 0, that must mean that the acceleration is also 0. So we kind of have to look at these graphs and say, right, which one of these graphs goes with no acceleration? All right, there was 2 sets that we really looked at in class. We looked at constant velocity and constant acceleration. We have dt, vt, and at. When there was constant acceleration, that's when your velocity graph was increasing and your displacement was kind of parabolic. That was constant acceleration. In the top case, this is constant velocity. When the velocity is constant, that's when the acceleration is 0 and your displacement is just increasing linearly. So we're looking for 0 net force. We're looking for 0 acceleration. That's going to be one of these graphs up here. And then we can see that it's choice 3. All right, 2 forces, F1 and F2, are applied to a block on a frictionless horizontal surface. If the magnitude of the block's acceleration is 2 meters per second, what's the mass? So F equals ma. Let's look at the forces on this system. We have 12 to the left and 2 to the right. So the net force on this system is 10 newtons. 2 to the right, 12 to the left. Gives us a total of 10 newtons. We don't know what the mass, we're looking for it. And they told us the acceleration was 2 meters per second squared. So can you solve this for m? Yes, divide each side by 2. And you should get that 5 kilograms is equal to the mass of the object. So let's see, number 7 here. We have a net force of 25 newtons is applied horizontally to a 10 kilogram block resting on a table. What's the magnitude of the acceleration? So in this case, they gave us a net force of 25 newtons, so F equals ma. The net force was 25 newtons. All right, it's a 10 kilogram block, and they want us to find the acceleration. Divide each side by 10. And we get 2.5 meters per second squared is equal to A. And then finally, 8. An object with a mass of 0.5 kilograms starts from rest and achieves a maximum speed of 20 meters per second in 0.01 seconds. What's the average unbalanced force accelerating this object? So in the end, we're looking for a force. We have to find a force. So if we want to find a force, right, and they've given us a mass, we're going to need to find an acceleration. So once we find an A, we'll be able to find the force. So if we want to find an acceleration, we're going to have to use one of those constant acceleration equations. So let's look at what variables they've given us. So in this question, the object starts from rest, so that's its initial velocity, 0. And it achieves a maximum speed of 20 meters, so that's going to be its final. They gave us a time of 0.01 seconds, and they want us to find the acceleration. So do we have a formula that deals with these variables? That's going to be VF equals VI plus AT. And so 20 is equal to 0 plus A times 0.01. So 20 equals 0.01 A. Divide each side by 0.01. And I'm going to get that A equals 2,000. Alright, so in the end we want to plug this in, get the force. So force equals mass. Now in this case the mass was 0.5. And the acceleration was 2,000. So the answer is going to be 1,000 newtons. Alright guys, that was the first video, so check out the other ones now.